This is Alican Canbay, a PhD student at the Ankara University Department of Physics. I need to close this one. Okay. PhD student at Ankara University Department of Physics. And I will talk about the VLQcalc Python module for calculating vector-like quark couplings. Actually, I can give you a brief introduction. Vector-like quarks are hypothetical new heavy quarks present in many extensions of standard model, and they are called vector-like because under the weak interaction, their left and right-handed components interact in the same way. Our model, it is used with these two MedGraph 5 models prepared within Fein-Rules framework. And our model's main features are converting couplings between models, decay width and branching ratio calculations, optimization of couplings with given branching and gamma to mass ratios, and creating a MedGraph 5 input file. Even our model has 5 submodules. Users can perform all the operations with model and MedGraph submodules. To understand the conversion of couplings, first we need to look at Lagrangians for models. As you've seen here, VLQ V UFO has reduced the free parameters of VLQ UFO model, and these equations can be used for conversion. But the VLQcalc module only takes into account interaction with the third family of standard model quarks, as their couplings are more dominant compared to other families. Here is the example of conversion of couplings. First, you need to create VLQ object coming from the model submodel, and this object has 3 parameters: VLQ type, FNS, and left and right parameters. Default value of the FNS and left and right are 4 and false respectively. SetMass method is used for defining the mass to VLQ object. And after for the convert model method, you need to give 3 parameters: kappas, branchings, and reverse parameter. Reverse parameters is actually defining the direction of the conversion. After you give these parameters, you can apply the convert model parameters, and you can see here for the VLQ UFO model, kappa is 0.5, and in the VLQ V4 UFO model, other kappas are calculating. For the validation, you can make inverse conversion here, and you can reach the initial kappa values. And also here another example of convert model method for vector-like Y quarks. Unlike the previous one, vector-like Y quark has only 1 branching and 1 kappa, 1 couplings. This is kappa W. For the decay width and branching ratio calculations, we are using the calc decay method. Calc decay method has 3 parameters: mass, kappas, and left-right parameters. Here, left-right parameters is coming from VLQ object. Upper example is vector-like T quark, and left-right is false. And this one, vector-like T quarks with left-right parameter, is true. And results are here. And also, this calc decay method is used for VLQ V4 UFO model actually, but you can use for VLQ UFO model after the model conversion. And this is the example of it. Using the gamma to mass ratio is actually important for narrow width approximation, and finding the kappa couplings for gamma to mass ratio is some kind of optimization problem. Our model is solving this problem with using modified version of genetic algorithm. Detailed information and performance tests of this algorithm on the additional slides and this GitHub page. And we are using this algorithm to calculate the couplings suitable with gamma to mass ratio. And this is an example for this. Gamma to mass ratio is 0.1 here, and calc ratio kappa method is used for calculating couplings. It takes 2 parameters, branching and the ratio parameter. This ratio parameter is float, and branchings, as you see here, it can be a list or single parameter for vector like y and x quarks. You can, after the performing calc ratio couples, we use this calc decay methods again for validating if we calculate correctly or not. As you see here, gamma to mass ratio is 0.1, so our calculations is correct. And also here you can use this method for VLQ UFO models, but you need to use convert model method again. After the calculation kappa method applied, you need to apply another method, convert model method, to find the couplings for VLQ UFO model. Also, our module can create a MedGraph5 input card. For this, you need another object, which is called MG5 object, coming from the MedGraph submodule. You can create this object while given VLQ object and the model name. And there is some methods also for this object. Set process method is used for defining the process, and also we have add process method to adding another process. There is shower detector analyzes properties also defined. These are consistent with MedGraph5 actually. And also we have add input method. You can define your number of events or center of mass energy with this method. And finally, you can use create MG5 input with the file name parameter to create a MedGraph input card. But you can, as you see here, set process and add process methods are actually expanding the your process, including particle and antiparticle, this ensures the most accurate event prediction statistically, actually. This example was for VLQ UFO models, and this is another example for VLQ V4 UFO models. In a result, VLQcalc allows for the conversion of couplings between existing model files, calculates decay widths and branching ratios, optimize couplings based on gamma to mass ratio, and generates MG5 input files for the given process. Actually, these features accelerate the event generation stage in the physics studies, of course, vector-like quark physics studies. In the future, if a new VLQ model is added to Fein rules model database, it will be integrated into the module, and new features can be added based on the recommendations. Thank you.
Thanks so much, Alikan. So, any questions? Otherwise, I can start myself. Okay, let me start doing. Yeah, you actually mentioned MathGraph, of course, and the integration, which sounds good. I don't know exactly how you are already discussing with them. But I also saw in the options there's delfs. So I wanted to ask if you're doing this within the framework of an FCC physics study, for example, or anything like that.
Actually, we have physics studies with vector-like quarks. This was the part of my PhD thesis, but we made it, we generalized this scripts to a module. And we are using, in the decay width and branching calculations, we are using the original formulas from VLQ V.UFO model, and the FNS is defined in this model.
Okay. Yeah. Thank you. Do we have any quick question then? Otherwise, we then continue. Oh, okay. Thanks very much again.